Hi guys. So let's just take a look at scientific notation. We've already looked at basically what the idea and purpose of it is. It's obvious for really large numbers or really small numbers, right? So let's look at some examples of scientific notation. So if I have something like 5, let's say 5.0. Okay, usually we have it to two significant figures, sometimes more than that, times 10 to the 3. We could also say that that's equal to, and this wouldn't be in scientific. Now we know this is in scientific notation because this number here, this is called the coefficient, right? This has to be between, so it has to be less than 10, but more than 1 or more. Okay, 1 would be the smallest. So this is what we could say this is A. And so A has to be less than 10, but it has to be more than, but it could also be equal to 1. So basically it has 1 digit to the left of the decimal. That's what we know, right? And then this is times 10, that's our base, and this is our exponent, okay? So what are some equal values to this that are not in scientific notation? Well, first of all, we know this is 5 times, and this would be 3 zeros, right? 10 times 10 times 10. So this is equal to 5,000. Or we can say, it is 5,000. 5,000 times 10 to the, that would be, really what we did here is we multiplied this by 1,000, so we would have to divide this by 1,000. So that'd be 10 to the 0. We could say it's equal to 50 times 10 to the, okay, so really what we've done there is we've times this by 10, right? So to make this equal, we would have to compensate here with divide by 10. When we divide, we lower the exponent by 1, right? And is that true? Okay, so that would be 50 times 100. Yeah, that is 5,000, okay? It's also equal to 500 times 10 to the 1, okay? But this is the only one that's in scientific notation. So this one here, this is scientific. Notation. Okay? All right, so we could represent it many ways, but if it's not in this form where we have basically the form has to be that we have 1 digit here times 10, and this is our exponent here, whatever that is, okay? So if it's 5,000, so if we had 5.0, this would be 3, right? So that is scientific notation. If it's not in that notation, we can make the conversions, okay? So we've established that. Now let's take a look at some multiplication where we're gonna multiply two very large numbers. So let's look at an example here. I'm gonna change colors here. Let's say I have 5.0 times 10 to the, I'm going to make it so that we cannot write these out in standard form. It would just be too painful. Times 10 to the 30 times, let's say 6.0 times 10 to the 24, okay? When we multiply, we know that we can change the orders. So I could change the orders. I'm going to go ahead and do that. So let me see. I'm going to go this part here. I'm going to say let's have 5.0 times 6.0, right? So I'm going to put that there. And then I'm going to say times, let's group this part here separately. Let's go with red. Times, so we have times, this part here is just, I'm going to put these parts here. So 10 to the 30 times 10 to the 24. So I missed that there. Now, can we do that? Can I change the order when I'm multiplying? like, sorry, say we have 3 times 2 and then 2 times 3, we know that those are the same value, okay? So I just changed the order. Now, why would I do this? Well, I want to cheat a little bit here. I want to use the exponent laws because, you know what, if I find out what this value is, it's got 30 zeros on it, and then multiply this, that's just a pain. Well, I want to keep this in scientific notation. This number is going to be way too big. So here, if I multiply 5 times 6, let me change colors again. So 5 times 6, that would be 30, right? So 30 times 10 to the, what do we do when we multiply the common bases? We add the exponents. Times 10 to the, that's 54. Okay. Is this in scientific notation? Let's go back and look. Well, we've got, the decimal place would be here, right? So that needs to be adjusted. So we need to change that to, let's see, that needs to be 3.0 times 10 to the, now what have I done? I've really divided here by 10. So I need to multiply, so what, to make it so that it's still equal to the same value. If I divide it here by 10, that will change the whole value. So that I have to multiply by 10 to undo that. So this would be, if I multiply by 10, this becomes 55, right? So 30 times 10 to the 54 is the same as 3 times 10 to the 55. Okay, so that's multiplication. We go ahead and do that. Let's take a look at when we do division. So I'm just going to make some space here. So we can use the laws, the exponent laws, when we do division as well. So I'll just give an example here. Let's say I have, let's start with black again. Okay, so let's say my example is here. I've got 4.5 times 10. Let's use some big numbers so that we won't have any. Times 10 to the 80. We would never have a number that big, but I'm just trying to show you the purpose that, and then we have 5 times 10 to the, let's say, negative 30. Well, this is going to be really big. Okay? So if we're dividing, what we can do here is I'm going to divide the coefficients separately, and then I'm going to divide the base 10s separately. Okay, so let's do that. So I'm going to have here 4.5 divided by 5, right? And then times, and then here I've got 10 to the 80 divided by 10 to the negative 30. Now it's kind of like what I did when I multiplied them, is I'm dividing the coefficients separately because that's going to give me the coefficient that we have when we divide, right? And then I'm dividing the base 10s separately here. So then I can just use the exponent laws, right? Let me fix this here because it should be 80. That looked like an 86 to me. It should be 80. Okay, so 4.5 divided by 5. Well, think about 45 divided by 5 was 9, right? So 4.5 divided by 5 would be 0.9. Let's change colors again. So this is actually 0.9 times 10 to the, what happens when we divide? That's going to be 10 to the, we subtract the exponents, 80 minus a negative 30. Now, if I'm subtracting a negative, I need to add, okay? So we're going to have 0.9 times 10 to the 110. Well, that's a big number. That's more than a Google, okay? But this is not in scientific notation, so we need to adjust that. That needs to be 1 digit to the left of the decimal. So we need to basically multiply this by 10. So that would be 9.0 times 10 to the, and since I multiplied here by 10, I would have to divide here by 10. So I'm going to lower the exponent here. So 109 by 1, right? Now it's in scientific notation. Okay?